Noble gas configuration. So, last couple days we were doing noble gas configuration, or just regular ground state electron configurations, and that can get tedious after a while. So I'm going to show you a shortcut. It's called noble gas configuration. So we look here. It says locate the noble gas that your element went through last. Okay, and I'll talk about this with the example. Then we're going to place the symbol of the gas, that noble gas, in brackets and finish off the configuration. So when we look at chlorine here, okay, what noble gas did chlorine go through last? That would be neon. So bracket Ne bracket equals, then we're going to finish off our configuration. So this bracket Ne bracket takes the place of 1s2, 2s2, 2p6. So we have bracket Ne bracket equals 3s2, 3p5. Okay, now orbital notation are diagrams that show electron configurations using arrows, and each arrow equals one electron. So an orbital containing one electron represents as follows, right? You're always going to use a spin up arrow before you use a spin down. So an orbital containing two electrons is as follows. You're going to spin up, and then you'll spin down. The lines are labeled with principal, quantum number, and sublevel letter. For example, the orbital notation for helium is written as follows. So helium, the electron configuration is 1s2. So then we're going to write the principal energy level and the orbital, so 1s underneath, and then we're going to write our spin up arrow and spin down arrow that'll show our two electrons. And we'll do some practice with this momentarily. So we're going to complete the ground state noble gas configuration. Well, let's just, we won't say that. This should say the ground state electron configuration. There we go, for the following elements. So we have lithium. So we look where lithium is in the periodic table. So our electron configuration, 1s2, 2s1. Now titanium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. All right, so now let's do some practice with some noble gas configuration. So the noble gas configuration for iodine. So iodine is right here. The noble gas that iodine went through last was krypton. So bracket Kr bracket. Now we'll have 5s2, 4d10. Remember, we got to subtract one energy level. We get to the d orbital, and then 5p5. If we get to the f orbital, we need to subtract two energy levels. Now we look at barium. The noble gas that barium went through last was xenon. So bracket Xe bracket, 6s2. Okay, so now some orbital notation for the following elements. So now we look. What we're going to do for these type of problems, I will specifically tell you if you could use a noble gas configuration or not to do the orbital notation. For fluorine, it's up on the table, up at the top, so we could just do the regular noble electron configuration. So 1s2, 2s2, 2p5. So now what I'm going to do is I have a 1s orbital, so I have one sublevel. So I'm going to write 1s underneath. Same thing here, 2s, one sublevel. Now 2p, I have 1, 2, 3 sublevels. Now I'm going to go ahead and put my arrows in. Now, depending on how many electrons I have, that's how many arrows I put. So I have 2 electrons here, so I'm going to spin up, and then I can spin down. That'll fill my energy level there. Same thing here, spin up, spin down. Now, this 2p orbital, we have a maximum of 6 electrons. I only have 5 electrons in fluorine. So I need to spin up before I get spin down. Remember, just like in our electron configurations, we're going to spin up. We're going to go left to right, Sorry why this is slanting. I'm not quite sure. And we're good there. Now, tin, 50, we'll use the noble gas configuration for this. So we have KR bracket KR. Then we have 5S2, 4D10, 5P, 5P2. So now 5S, remember D, 5 sublevels. Spin up, spin down, up, 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 and then we'll spin down all the way through because we're going through that d orbital. And then we're going to spin up and spin up. And this concludes our video on noble gas configuration and orbital